Observe the scale of a modern commercial jet sitting on the tarmac. Fully loaded, it weighs as much as several hundred elephants. Basic physics dictates that a heavy stone falls instantly when released. Logically, a machine of this colossal mass should remain grounded rather than crossing oceans. Sustaining flight requires a precise orchestration of components to balance the constant pull of the planet. Lifting this much metal into the air depends on a specific sequence of aerodynamic events. For thousands of years, humans could only observe the flight of birds while attempting to replicate their survival in the sky. In 1903, Orville and Wilbur Wright demonstrated that a powered engine and a controlled wing could achieve sustainable lift. Their first successful attempt lasted only 12 seconds, but it proved that human flight was a mechanical reality. This diagram illustrates the four forces acting on every aircraft: gravity pulling down, lift pushing up, thrust driving forward, and drag resisting movement. The success of a flight depends on keeping these four opposing forces in equilibrium. As the aircraft begins its runway roll, the engines generate the first critical force, thrust. While it may look like the engines pull the plane upward, their actual function is to provide extreme forward momentum. This cutaway shows how a jet engine operates. It draws in massive volumes of air, compresses it, mixes with fuel, and ignites. The resulting high-pressure gases are expelled out the back at high speeds, creating the forward thrust necessary to accelerate. Without this rapid forward velocity, the wings cannot generate the forces needed for takeoff. As the runway speed peaks, the physical forces shift from the tires to the aerodynamic surface of the wings. This 2D cross-section shows the wing's curved upper surface and flatter bottom. Moving forward, the airfoil splits in air. Air over the curved top moves differently than air underneath, creating a pressure difference. Deflecting air downward produces lift, shown by this upward vector. When the upward force of lift exceeds the total weight of the aircraft, the pilot rotates the nose upward to begin the climb. The wheels leave the runway as the aircraft achieves a state where air pressure overcomes the pull of gravity. The airplane continues its ascent until it reaches a cruising altitude of approximately 35,000 feet. At this height, the atmosphere is significantly thinner. Thinner air offers less resistance, which drastically reduces the force of drag. Lower drag allows the engines to operate more efficiently, conserving fuel during long-distance travel across oceans. Outside the cabin, the environment is freezing and the air is too thin to breathe. Interior systems maintain a pressurized, comfortable environment for the passengers. When the ride gets bumpy, the aircraft experiences turbulence. This results from uneven air currents, much like a boat navigating choppy water. Aircraft are designed to flex and absorb these movements, ensuring the structure remains safe even in rough conditions. To return to the ground, the airplane must intentionally decrease its airspeed and surrender its altitude to gravity. Pilots deploy wing flaps to change the airfoil's shape. This allows the wings to continue producing lift even as the plane slows down for its approach. The landing gear extends to support the aircraft's mass as the tires make contact with the runway. Engines then utilize reverse thrust, working with the wheel brakes to counteract the remaining forward momentum. The aircraft slows to a halt, completing the mechanical sequence of the flight. Engineers are now applying these same principles to address the environmental impact of aviation. Future designs include aircraft powered by electricity, hydrogen, and solar energy, moving away from traditional combustion. These sustainable technologies aim to provide global connectivity while reducing the industry's carbon footprint. Aviation succeeds by turning the laws of physics into a partner rather than an obstacle. Every aircraft in the sky represents a sophisticated harmony between human engineering and the invisible forces of the natural world.